right, the next question. Okay, so I have actually added, since I was doing it with the mouse, I've added my scaling on both my axes. So again, same kind of process. I look at the end first, it says at +2. That means I need to put a dotted line at +2, and I will make it green, which it is, so +2. Then what happens is I look at my amplitude. My amplitude says 0.5. So if it's 0.5, it means that I need to go down 0.5, so 1.5, and up 0.5, so 2.5. So my graph actually fits in between there. You can see that it's going to be tiny this time. The next thing I look at to see whether I have sine or cos. In this case, I have sine. Sine starts in the middle, so it's going to start at 2. So point at 2. Oops, I want red. At 2, I go up, then I ping pong down, down, up, up, down. Okay, so, and in most cases, they will ask for one complete period. So in that case, it would be 360. Sometimes they'll ask for 2 periods, and you could actually just keep adding 90 to the numbers to the scale if you so wish, and then you would end up with the rest. Okay, so now it's just a matter again of a nice smooth curve, a little bit harder maybe when it's tiny like that, but maybe not. Maybe it's easier. Okay, so again, looks very, very similar. All we've done is we've changed the amplitude, we've made it shorter, and we've moved the whole graph up. So let's look at the next one. The next one is y equals -2 cos x plus 1. Again, I'm going to pause this and put, you don't need to watch me draw some numbers. Okay, so again, we look at the end. It says +1, so we need to have a dotted line at +1. And we make it purple because that's what I chose. So at +1. Then I look at the amplitude. The amplitude is 2, even though I have a negative here. So it means I need to go up 2. So now I'm at 3 and down 2, which means I'm at -1. And cos normally starts at the highest and comes down. Because of that negative here, it means that I'm going to start at the lowest spot and go up. Lowest spot, go up. Okay, but the same kind of process. It's just a ping pong ball, ping ponging around. Not sure whether I like that purple and red together. It's kind of funky. And again, our nice smooth curve, or as smooth as you can get it. Okay. So really not too difficult. Now I'm surprised I didn't ask for the domain and range. Oh, I did ask for the domain and range and amplitude and vertical displacement. So it means that I have to go back and state it for the other one. Sorry about that. So you'll just have to go back and look at that example again. Okay, so if we go back to this first one, let's look at the domain. The domain is x is the set of real numbers, so that hasn't changed. Our y is also in the set of real numbers, except we know that our y, oops, I wanted y, such that y is going to fit between 3 and 1, so -3 and 1. So -3 is my lowest, +1 is my highest. My y has to fit between those two. Okay, our amplitude here was 2. I'm going to put the absolute value of 2. And the vertical displacement, well, we went down 1. So I would put the word down 1. Just don't put -1. Okay, let's go look at our other two that we just finished doing. Okay, this one here, again, our domain is x's in the set of real numbers. And you're saying, is that always true? For the most part, it is for the ones that we're looking at this year. Our range is also a real number such that we know that this time it's changed. So y is going to fit between two numbers. The two numbers it fits between, the lowest number is, remember, 1.5 and 2.5. Our amplitude was 0.5, absolute value. And our vertical displacement, this time we went up 2. And finally, our last one, again, x is the set of real numbers. So is our y. And remember that y is going to fit between, in this case, -1 and 3. And our amplitude is the absolute value of 2, or of -2 if you want, because that comes out as a 2. And our vertical displacement, we went up 1. Okay, so some questions for you to do from a worksheet.